All right, hello. This is a video I'm making to show you how to do all the problems on the Chapter 4 test, okay? A couple reasons to do this. One is that you can access it and rewind it, and it's not like real life where I have to repeat. You can just rewind it and watch as many times you want on the problems that you have trouble with. Fast forward through the ones you didn't have trouble with, but also a way for you to check all your answers and see how I would get all the answers, okay? So let's get busy. Usually when I make an answer sheet, I call it llave, which is Espanol for a key. That's my answer key, right? All right, I'm making this after you took the regular test here. And put the date there, right, and the period. I have math both third and fourth, so I'm going to use it for both. First question, write 142% as a mixed number in simplest form. A mixed number, remember, is going to have whole numbers and parts of numbers, right? Usually when they're asking us, they want a fraction, but technically, if I just made this a decimal, moved it, remember to go from percent to a decimal, you just move it 2 spots to the left. Technically, 1 and 42 hundredths is a mixed number. Right? The fact that they said simplest form kind of implies we're looking for a fraction, though. So 142% is 142%, means per 100. You can take whatever percent it is and make it a fraction by writing it over 100 and then simplifying it. Now, 100 goes into 142 one time, so that's 1 whole and 42 hundredths. Okay? But that isn't in simplest form. I know that because both these numbers are even, so I know that 2 goes into both those numbers, both 42 and 100. How many times does 2 go into 42? 21. How many times does 2 go into 100? 50. So 142% is 1 and 21 fiftieths in simplest form. I put a little fancy 1 in there because that 1 was kind of looking like it is a line there. So 1 and 21 fiftieths. And again, whenever something's more than 100%, it's going to be more than 1 whole. Okay? All right, 23 over 25, write as a percent. There's 2 ways of doing this. Okay? The way that works for all fractions is you divide the bottom into the top and make it a decimal, then move the decimal 2 spots to make it a percent. So it'll never fit unless it's improper, so 25 won't fit into 23, but since I'm making it a decimal, I'm going to put a decimal there, bring it up, put a 0 there. Now I'm going to count by 25s up to 230, or close to. Right, I got 25, 50, 75, 1, that's 4, 25, 50, 75, 2, that's 4 more, that's 8. Another 25 makes 225, so I'm going to go 9 times here. And 9 times 25 is 225. When I subtract, I get a 5 here, right? Because I had to borrow 10 minus 5. And so since I have a remainder, I'm going to add a 0 and do this again. And 25 goes into 52 times. So that's my decimal. And to make that a percent, I just move it over 2 spots. 92%. That's my answer. Now, show you a shortcut that doesn't always work, but it works with this one. If your fraction has a denominator, that's the bottom number, that fits into 100, right? Then you can get an equivalent fraction with 100 on the bottom. You just figure out how many times you had to multiply that denominator times to get to 100. Now in this case, 25 times 4 equals 100, so I have to multiply the 23 times 4, and that equals 92. And anything over 100 is that many percent. 92 per 100 is 92%. So that's another way of getting that. Doesn't always work, but if the number fits into 100, the number on the bottom, then you can do that shortcut if you want. Okay? All right, 14% to a decimal. These next 2 were the easiest problems on here, if you paid attention. That's a big if for some of you, right? It's easy to change the percent to a decimal or decimal to percent. You just move the decimal 2 spots. From percent to a decimal, you move it 2 spots to the left, so 14%. If it was here, right, and if you can't see it, it's on the right. Move it 2 spots, it ends up in front of the 1. So 14% is 14 hundredths, or 0.14. I put the 0 there whenever there's a decimal and not a number in front of it, so you recognize there is a decimal there. Okay, 23%, 2300, sorry, adds a percent. I'm just moving it 2 spots the opposite direction now. It starts here, move it 2 spots, now it's in front of the 3. And if it's on the far right, you don't need it. 0.23 or 23 hundredths is 23%. Okay. Next one, unpacking a box of canned vegetables. You notice that 2 out of every 40 cans are dented. Write 2 out of 40 as a fraction, a decimal, and a percent. 2 out of 40, that's 2 over 40. Now, it did not tell you had to simplify that or write it in simplest form. I want you to start doing that, though. Whether it tells you to or not, you almost always want it in simplest form. So since 2 and 40 are both even, I know that 2 goes into both. 2 goes into 2 one time, into 40. Okay? I didn't mark it wrong if you had 2/40ths, because that's a fraction. All right? Now, for a decimal, how do I get a decimal? Well, I'm going to divide the bottom into the top. And so 20 into 1. It won't fit, so I have to add a decimal and bring it up and add a 0. And guess what? It still won't fit. I got to put a 0 up here now. I got to say it goes into 10 0 times 20 is 0. Subtract, add another 0 and bring it down. And now 20 goes into 100 5 times. Perfect fit. So 1/20th is the same as 5, make this right, 5 hundredths, 0.05. That's not, I started to write 0.5. That's 50%, right? That's half. That's not right. Half the cans are dented. We're sending that back, right? All right, so 5 hundredths, and again, to go from a decimal to a percent, I'm just going to move it 2 spots that way to the right. So it's here, boom, boom. It ends up on the other side of 5. 5% of those cans are dented. All right, so this is the fraction, decimal, percent. Start boxing your answers, please. Right? Put a box. I should be able to find your answer. You should be able to find your answer easily. Okay. Now I'm comparing a decimal and a percent on the next one, and it's easiest to compare if I make them the same. Okay. Usually easiest to change things to decimals, right? But you can change the 37 hundredths to percent if you want, and say 37% or 41%, which is bigger. 41%, remember the arrow points to the small one. If you change the 41% to a decimal, you had 0.41 compared to 0.37. 0.41 is bigger than 37, right? So, which one's greater? I'm going to go ahead and circle that 41%, and I've showed enough work, right? I'll show you 2 different ways, actually. All right, this next one is a little harder, but same idea. I'm comparing them all these numbers. Okay? And the first time I did this, I was looking at it, I finally realized this here, it looks like it starts as a decimal. It's a percent. So really, look at this. That is less than 1%. It's only a little more than 0.9%. All these others are way bigger than that, right? Right? So if I change these all to percents, that's going to be my first one. A lot of people miss that, right? Because it had that fraction of a percent. That's smaller than 1%. Okay? Now let's see what's if I make them all percent, it's easy to compare. Move these decimals over 2 spots. So this is 9.2%. Move this over 2 spots. This is 9.9%. This is already 93%. Whoa, that's way bigger. And 9 over 10 is the same as, remember, if the number on the bottom fits into 100, I can say 9 per 10 is how many per 100? Well, I did 10 times 10, so I go to 9 times 10. So this is 90 over 100, which is 90 per 100, or 90%. Or I divide the bottom into the top, make it a decimal. It would be 9/10, I move it over twice. So this is 90%, this is 9.9% or 9.2%, and that last one I haven't checked yet. Oh, it's already done for us. It's 93%. So made them all percents. Which is the next smallest? Looks like this 9.2. Right? And the next smallest, 9.9%. And the next smallest, right? It looks like it's 90%. and the last one is 93%. Now, when I do this, I kind of like to actually go write the original numbers again so I can find out which one's which. So this was already written as a percent, so I'm going to rewrite it. 0.915 or 915 thousandths of a percent, right? Less than 1%. This 9.2% was really originally 0.092. They equal the same, but let's write them how they were when they started. This next one, 9.9%, was 0.099. This 90% was written as a fraction at first, 9/10, and this was written as a percent already. All right, I'll use that for my answer because those were the original numbers, and now they are from least to greatest, smallest to biggest. Next, 40% of 115 is what number? Again, when we translate in English to Mathish, that word of in English is almost always multiply in Mathish. So I'm going to cross out that word of, and I see another one here. Okay, and 40% I can write as a decimal. I'm going to write that as 0.4, right? Move it over 2 spots. 0.4 times 115. What does is mean in math again? That means equal, right? So 0.4 times 115 is what number? Well, that's just a big question mark. I don't know, right? So I just have to multiply 0.4 times 115. When I multiply decimals, I pretend there's no decimal and multiply first. And that's 20, carry the 2, 4 plus 2 is 6, and 4 times 1. And then when I'm done multiplying, I go figure where the decimal is going to go. I have one number to the right of the decimal in my problem, so I have to go back 1 spot in my answer, right? 1 spot, I get 46. 46 is 40% of 115. That makes sense. Because 40% of 100 is 40. 115 is going to be a little more than that, 46. Now this one's a little trickier. I'm going to translate though. 60% I can write as 0.6. Of means times. Now it says what number? I'm going to put a question mark there. Is 33. Okay? So on this, I'm going to use a fact family. Now this week we've started learning how to do algebra problems, right? I can use a variable there and do some solving the equation, but we're just going to use fact family. This is how we taught you how to do it at first, which is fine. Remember 6 times 7 equals 42. I can flip these around and say, well, if that's true, then 42 divided by 6 equals 7. So if I have this times that equals 33, I can say, well, that means 33 divided by 0.6 equals this thing I'm looking for. All right, so I'm going to divide. Now, dividing with a decimal outside the box, 0.6 into 33, you got to be careful. You can't do that. You got to get rid of that decimal outside the box. How do you do it? You got to move it all the way to the right. In this case, I only have to move it 1 scoop. But remember, if I move it outside, I got to move it inside the same distance. Okay, so I moved it 1 scoop outside, I got to move it 1 scoop inside. If I moved it 2 outside, it'd be 2 inside. 3 outside, 3 inside, right? And then when you get done moving those decimals, spend 4 seconds rewriting the problem. This is real confusing looking, but if I write what my problem is now, it's just 6 into 330. Okay, now I got a division. 6 goes into 33 5 times. 5 times 6 is 30, and I subtract. Bring down the next number. Daniel Martinez loves this. You hear that, Daniel? Shout out. How many times does 6 go into 30? That's another 5. So my answer is 55. 60% of 55 is 33. Boom. All right, next problem. The next one shows, this table shows the portions of cotton in 3 shirts. Which shirt has the highest, I'm looking for a bigger number, right, portion of cotton? And this is written as a percent, this is a fraction, this is a decimal. So all we're doing is comparing. Okay, what do you want to change? Usually it's easiest to change to decimal. It's easy to change this to decimal, move it over 2 spots, 0.80. I'm going to leave that O because this comes out 2 spots also. I know so far this is bigger, so I know this isn't going to be your answer. But how about this one? Again, this fits into 100. So there's 2 ways of doing it. I can say 25 times 4 and 21 times 4. So this is 84 hundredths or 84%, or 84 hundredths can also be written as 84 hundredths. Remember, if you close your eyes and I say 84 hundredths, you don't know if I said that or that, because you say them the same. But back to the problem, which is bigger of these 3? 84. So we're going to say B is the biggest of the 3. All right, time to flip it over. Second side, I got beverage A and beverage B are sold in identical cans. Beverage A is 8% sugar, and the portion of beverage B that is sugar is 0.28. So they did a percent on one and a decimal on the other. How many times more sugar is in beverage B than in beverage A? So there's 2 ways you do this. Okay, first I got to compare, right? So since this is a decimal, this is percent, I'm going to change them both to decimals. 8%, move it over 2 spots. From 8, 2 spots, I got to put a egg in a carton is what we say, right? So 0.08, right? So this is 0.28, and this is 0.08, okay? So if I multiply both sides by 100, this would be 28, and this would be 8, okay? So I'm trying to figure out how many times bigger is 28 than 8? Well, basically, I got to divide that 8 into 28, okay? 8 into 28, and it goes 3 times, but I have a remainder here, so that kids get confused what to do with the remainder, okay? Well, if I'm dividing, I could just put a decimal, bring it up, and add a 0, bring it down, and keep dividing, right? Because 28 is the same as 28.0, and that's the same as 28.00. I can keep adding zeros and keep dividing if I want. And if I do that, this is so much easier, because 8 goes into 40 a perfect 5 times. So that means that 28 is 3.5 times bigger than the 8, right? So B has 3.5 times more sugar, 3.5 times. And I'm going to write more, because the question was how many more times. Okay. All right. You lose an online auction for an autograph. Your losing bid is $42. $42 is 60% of the winning bid. So 42 is 60% of the winning bid. So how much less was your bid than the winning bid? Well, how much was the winning bid? I got to figure that out first. What does this mean? How can I write 60% as a decimal? And what does of mean? Times. So 0.6 times this winning bid is 42. Well, if that's true, then 42 divided by 0.6 should be the winning bid. Okay, so I got to divide. 42, I got a 0.6 out here. Uh-oh, can't divide with a decimal outside the box. What do I got to do? Yep, I got to move it to the right. If I move it to the right, I get rid of it. But, uh-oh, if I moved it outside, what do I got to do? Move it inside, same number of scoops. There was only 1 scoop. There's nothing there. Fill in the egg carton. And again, if you're smart, don't divide with all these decimals and scoops. Spend 3 seconds rewriting it. And guess what? 6 goes into 42 7 times. So 6 goes into 420 70 times. Now, I have to admit, the first time I did this, I thought it was done here. I figured out that winning bid is 70. But what you should always do is when you get done, go read the question and ask yourself, does that make sense? Okay? And that last question, they say, how much less was your bid than the winning bid? Oh, they didn't just want the winning bid. They want to know how much less your bid was. And your bid was 42. How much less was it? We're figuring out the difference. And it ends up being $28 less. So I had quite a few kids on this one and this one do a lot of work, real smart work, get an answer, but not answer the question that was asked. Make sure you always double check that, okay? All right, this one here. The width of the rectangle is 60% of its length. That length is 40. So this width here is going to be 60% of 40 feet. Okay, what is that? That's 0.6. What does that mean? Times 0.6 times 40. When you multiply decimals, you pretend there's no decimal, multiply. 6 times 40 is 240. And then you have to go back. How many spots? Well, how many numbers to the right of the decimal in your problem? There was only one, so I'm going back. So that width is 24. If you got that, great. But that's not what they asked. You needed that to find out what they asked. What they asked was, what is the area of that rectangle? Area of a rectangle is easy. You just multiply the width times the length. So I got to go 40 times 240. 4 times 24 is 96. So 40 times 24 is 960. Feet times feet is square feet. Area equals 960 square feet. Make sure you have the right units. All right, next. Again, that was one. You can do all that work to get that 24, but that was just part of what you needed to get what they were asking, the area. Restaurant holds an anniversary celebration of 90 diners who visit during the anniversary celebration. 27 are offered free dessert. What percent of the diners are not offered free dessert? Ooh, that is mean. 27 out of 90 are. 90 minus 27 is how many weren't. I gotta borrow. 10 minus 7 is 3. 8 minus 2 is 6. So 63 were not offered, but they want to know what percent that is. Well, 63 of the 90 is the fraction. If I want to turn that to a percent, 90 doesn't go into 100. I got to divide the bottom into the top. That's going to give me a decimal. Then I'm going to move it over twice. So it doesn't fit, so I'm adding a decimal, bringing it up at a 0. And guess what? 9 fits into 63 7 times. So 90 times 90 times 7 is 630. So 0.7 is the decimal, and to change that to percent, I'm going to move it over 2 spots. And if I move it over 2 spots, boom, boom, I got to fill in that egg carton. 70% were not offered. Okay? Lots of ways to trick you on that one. I thought that was almost mean. These next two were so hard, I gave you extra credit if you got them right. Okay? And I'll add that to another video. See kids doing these first 14. Actually, let's just add them. Let's do it now. You can stop now if you weren't worried about the extra credit. But this was kind of this is a good puzzle problem. They're saying, what number can I replace for A? And I got to do it in both. Same number. I can't put a 2 here and a 6 here. Would make this so this number is smaller than this number, and this number is smaller than 81%. Okay? And for me, I just did some guessing and checking, right? If I had this be a 3, then I'd have 3 over 3. That's 1 whole, and I already know that won't work because that's bigger than 81. If I had it be a 6, right? Then 3 over 6, that's small. That's only a half. That's going to be smaller than 81%. But then I got 6 over 5. That's bigger than 1. That's bigger. So 6 ain't going to work. What if I did a 5? 3 over 5, that's less than 1 whole. That's less than 81%. 5 over 5 equals 1, though. That's bigger, right? Let's see, 4. 3 over 4, I know that's about 75% because 3 out of 4 quarters is 75 cents. And then 4 over 5, ooh, that's 80%. Because every fifth is 20%, right? And that's smaller than 81%. So the 4 is what worked there, right? Now, what that has to do with what we're doing, not a whole lot, a little bit, because you're comparing the fractions and decimals or percent. But, yeah, that was sort of a puzzle-type problem. Yeah, and the best way to get that, I think, is guess and check. Okay. All right. Building has two sizes of apartments, small and regular. The ratio of small to regular is 17 to 3. So I'm going to put an S and a regular there. What percent of the apartments are small? Okay, so 17 to 3. When I add 17 plus the 3, I get 20. Okay, and the small ones, that was 17 out of the 20. 17 out of every 20 are small. What percent is that? Well, this is one of the ones that 20 goes into 100. How many times did I multiply the 20 times to get 100? By 5, so I do 17 times 5, that's 85. 85 per 100 equals 85%. Okay, I think that was doable, but since 15 was extra, I made that extra. Okay? All right, hopefully this helps, and hopefully you will study these problems, ask me questions if you don't get them. So if you do the retake, you do better, and if you don't do the retake, hopefully you've learned something here. All right, cool.